So it says find the infinite sum if it exists for the series, and they give us a series here. Let me write it. So minus 3 plus 0.6 plus negative 0.12 plus dot, dot, dot. So it goes on forever, right? Infinite. That's why the dot, dot, dot. Infinite. So that's interesting. We've changed gears on this question. We're letting the series add up forever. Interesting. Okay. So, well, first off, what's happening from term to term? What's going on? Well, we got to find the R. So we got to find, and that's right here. R, the ratio, is second term over first term. Second term over first term. So here's the second term. Here's the first term. So the R, the common ratio, second term over first term. So it's going to be 0.6 divided by negative 3. You divide those on your calculator. I'm going to do that. We're getting negative 0.2. So what that means is that's what it's multiplying by every time. Is that true? Let's check that. Is it going times negative 0.2 and then doing that again? Times, is it multiplying by negative 0.2 every time? Does that work to go from here to here? If you check it on your calculator, it does. That's what it's doing. Every time it's multiplying by negative 0.2. That's the R, the ratio, the common ratio, what it's multiplying by every time. Well, okay, so how do you find the infinite sum? If you look down at the notes here, for a geometric sequence, and down here is S sub infinity, which means for a sum of an infinite number of terms, it may only be used when R is between negative 1 and positive 1. If R is bigger than 1 or smaller than negative 1, then the infinite sum diverges instead. So there's the formula, but you can only use that formula when R is between negative 1 and positive 1. If it's not, you say it diverges. So let's go see. That's why they said if it exists. So our value is negative 0.2. So the question is R between negative 1 and positive 1? Well, here's negative 1. Let's do a number line. Here's positive 1. Here's 0. Where's our R value? Negative 0.2. It's about right there. Negative 0.2. So yeah, our R value is between negative 20. Yes, between negative 1 and positive 1. Yes. So it's okay to use the formula. So S sub infinity, infinite sum, is A1 over 1 minus R. What's A1? First term right here. Negative 3 over 1 minus, and what's R? Negative 0.2. Watch out there, really easy mistake to make. Over the years of my teaching, many students I've seen make that mistake, right? The formula is A1 over 1 minus R, and R itself turned out to be negative. So it's minus a minus, you get it? So it's negative 3 over 1 plus 0.2, so it's negative 3 over 1.02. Divide that on your calculator, that's what I'm doing. I'm getting some big number. So it's going to be negative 2.941176471. I don't know how many decimals they want. Let me check how many they require on this one. Yeah, you can just put in a bunch of decimals. I'll take it. And so there we go. So again, what did we do? We looked at the three terms. We found the common ratio by taking the second term over the first. Negative 0.2. We double check that. Is that multiplying by negative 0.2 every time? Yeah, it works. So that is the R. Is that R between negative 1 and positive 1? Yeah, negative 0.2 is right there between negative 1 and positive 1. So it's a yes, and therefore it's okay to use the formula. If it was not, if the R was out here or back here, then we would just say diverges and be done. But this one works, so we can use the formula. We plugged in A1, we plugged in R. Careful with the sign there, negative. So 1 minus negative is 1 plus. Divide that in the calculator. There we go.